When we're asked to simply match the equation that's given with an actual graph, arguably not necessarily the fastest approach, but the easiest approach would be Desmos. So let's go ahead and open it up. And I was actually playing around with this. Let's say you have a function here, you'd click the gear icon and delete all. Now, the reason I was playing around with it is because I hadn't realized this about Desmos. One, you definitely don't need to put y equals if it's just y equals. That part's kind of a giveaway. But let's go ahead here, and when we type this in, you could do the exponent right here, the a to the b. I like just doing shift 6, which is the caret function. Now when I type in x, and I do +1, notice right away it like dropped it down to a big one, and that's not what we want. And so I kept playing around with it. I'm like, what's going on? How do we do this? So you actually have to put a left parenthesis here, and then you're able to type it in. Now, whether or not I close the parentheses, up to me. If I press enter, it'll do it anyway, and I don't even need to. But let's go back to the beginning. So if I did 2 to the, right away you'd put a parenthesis because the exponent's more than just x. And then again, I don't have to close it. So now we're going to look for which function looks like this. Well, the thing that you would recognize most readily is like it definitely is getting closer and closer to the x-axis without touching it. So that means we could definitely eliminate the ones that look like it has a different kind of horizontal asymptote other than the x-axis, which is option B and even D. And then also, this is clearly exponential growth. So we could eliminate option C, which was decay, and then we actually found the correct answer is A. However, you know by now, I like you to actually understand the math as well. I think just understanding how functions, characteristics get displayed is just a good thing to know. So let's look at a couple key things that really could help you get the answer quite quickly as well. So for example, if let's say I wanted to plug in a specific value and see which of these graphs do have that ordered pair, typically you want to plug in 0 for x, and if I plug that in, we have 0 plus 1, in other words 1, as the exponent. 2 to the first is 2. So we have 0 comma 2, and let's go in and see which ones we can eliminate. This one does have 0, 2, so does this one. So then when I scroll down, really only C appears to be the only one that doesn't have 0, 2 as an ordered pair. It looks like 0 comma 1, because it's halfway between 0 and 2. So we could eliminate it, and really that's the only one. Now the other thing that arguably is actually the fastest thing to recognize, the fact that this base is a 2, which is larger than 1, tells us it's an exponential growth function. If ever that value is between 0 and 1, typically as a proper fraction or as a decimal, then we know it's exponential decay. But since this is exponential growth, A and B are both good because they're exponential growth, but notice that option D is decay because it's falling from left to right. And then finally, notice the key difference between these two is this first one, option A, has a horizontal asymptote at the x-axis, in other words, y equals 0, and option B has a horizontal asymptote at y equals 1. And the way you determine the horizontal asymptote is, let me actually rewrite the function to see it a little more clearly. You have the exponent, and then whatever is at the very end, in this case there's nothing, so it's a 0, that's the horizontal asymptote, y equals this number. So since it's really y equals 0, it's not y equals 1, and we get the correct answer is A. So keep in mind, you could definitely use Desmos, but again, it's just good to understand some of the characteristics.